my name is Tyler Soper, and this is my presentation on the Golden Spike Tower project. Next slide. The project goals were to create a three-dimensional model of the Golden Spike Tower and learn how to acquire information as an engineer. Next slide. A little bit of history. The idea of the Golden Spike Tower and Visitor Center was first conceived in the mid-1990s as Union Pacific's own viewing platform was falling into disrepair. Community leaders thought it was a good idea to erect a tower that would allow visitors to get a bird's eye view of Bailey Yard, and the Golden Spike Tower Visitor Center opened on June 26, 2008. Next slide. Acquiring plans. Originally I had planned to get a copy of the plans from the North Platte City Hall's planning department. Unfortunately, they were unable to find their copy and referred me to the original architecture company, CG Architects. Next slide. Creating the model. The next few slides are some pictures of my progress while building the model. Here you can see the top section of the tower. Next slide. Here you can see the nearly completed product of both the top and bottom sections. Next slide. Here you can see the nest with its handrail. Next slide. Here you can see the peg and hole I added to the tower and the top respectively that would make attaching the top more stable. Next slide. I hope you enjoyed my presentation and you found it informative.
I'm done, thank you.
This is my Golden Spike report on the tower in North Platte, Nebraska and Bailey Yards. To find the dimensions in the building, it took up a lot of my time in the project. Many of the basic dimensions were on the website, but a height such as the height and square feet. Yet a lot of the dimensions I had to come up with by other means to figure them out, such as the dimensions of the windows and the offset balcony of the upper front side of the tower. Many of the dimensions I still do not know. When designing the tower, I noticed that the top had an odd pitch to it. The building was an irregular octagon, and the overhang of the roof was a little more complex than one would think. I started out creating the base by making the shape of the irregular octagon. Once lengthening that to the height desired, I began to create the point of the roof that makes its tower spike. Once that was completed, I moved on to the offset balcony that is below the main overlook on the top floor. This was tricky because the polygon design of the building made it hard to create the landing on with the overlook was set. Once the balcony was complete, I began to lay in the guidelines for the windows that would surround the entire top floor. Each window had a different way it was set, or just the general dimensions all around. To finish the project, I placed support beams around the overhang that surround the top floor. And this is what the project turned out to look like.
Hi, I'm Shannon Morse, and I will present my presentation over my 3D printer prototyping project. First, I will offer background information on SketchUp by providing information over the history of SketchUp and how it works. Next, we will look into the project specifications, and I will then explain the design process of the Spike Tower and Visitor Center. Finally, I will present my results. SketchUp was created to be a 3D modeling program that is powerful yet easy to use. Some people think that it was originally created by Google, but actually it was first brought to us by Atlas Software, a tech company co-founded in 1999 by Brad Sichel. With an original release date in August 2000, Sichel and his team developed SketchUp as a 3D modeling tool for architects, designers, and filmmakers. After the successful launch of SketchUp, Atlas wanted to allow people to be able to place the models they've created in SketchUp into Google Earth. They collaborated with Google to develop a plugin to allow people to geolocate their models in Google Earth. As a result of the collaboration for the plugin, Google was impressed with the work of Atlas Software and purchased the company in March 2006. The 70 employees from Atlas kept their jobs, but in return became employees of Google. Thanks to Google, this software is available for free. SketchUp is a 3D wireframe modeler. That means when a 3D rectangular object is drawn in SketchUp, it is a hollow box and not a solid cube. When using SketchUp, objects can be colored in to give a more realistic surface, such as glass or brick. SketchUp is not a photorealistic modeler, but it can present a close enough approximation to get an idea across quite well. Like any good program, SketchUp allows components or pre-drawn elements to be placed into the drawing. These can include both 2D and 3D items such as people, vehicles, trees, and more. Components can also be drawn by any individual using SketchUp. SketchUp offers several different formats for display. It is capable of saving the drawing with several different view settings. These views are called scenes. These scenes can be turned into a sort of animated presentation of the project if desired. These can also be used to save a particular view for printing or, for example, a section cutaway. These are quite helpful in full visualizations and presentations. A 3D model of North Platte Spike Tower and adjacent visitor center is to be designed. The design needs to be up to scale, and the roof of the tower is to be designed separately. The first thing that was done was researching the building. The only information that could be found online as far as dimensions was that the tower was 8 stories tall. After a few phone calls, it was concluded that the measurements could not be determined early enough to allow time to finish the project. As a result, estimations were made based on the information that was found. Assuming that each story is 11 feet, the rest of the tower and adjacent visitor center was able to be measured by using pictures. To begin designing the tower in SketchUp, a hexagon with dimensions of 46 feet in length and 24 feet in width was made. The edges of this hexagon was offset by 2 feet inward. The push-pull tool was then used to increase the wall by 77 feet. After the base was constructed, the floor of the indoor view and balcony were created. By using the same method, a 61 by 49 foot octagon was made for the indoor view. Guidelines were used to construct the balcony floor. Railing was put on the balcony by first making a few rails and posts and turning them into components to copy and rotate to the correct position. Windows were made and a small entrance building was built to complete the first task of the project. The next task was to design a roof for the tower. First, a 51 by 63 foot rectangle was constructed. It was push-pulled upward 3 feet and guidelines were used to help create the rooftop. To finish the second task for the project, the roof was painted to make it look more realistic. The measurements of the visitor center was estimated by using pictures and comparing it to the Golden Spike Tower. The known components that could be seen with pictures were recreated in the model. First, a 62 by 20 foot rectangle was created and push-pulled up 11 feet. An 88 by 24 foot rectangle was then placed on top of the existing rectangle for the roof. The visitor center roof was constructed by using the same steps as the roof for the tower. The result was a roof that was 12 foot in height. Columns, doors, and windows were made with the help of using the basic functions of the push-pull tool. More details such as supports, windows, and colors were added to complete the final task for the project. A 3D model was constructed by looking at pictures that were found online. The final result was a spike tower reaching a height of 102 feet with a width of 24 feet and 46 foot long. The adjacent visitor center was 23.5 feet tall with a width of 20 feet and a length of 84 feet. The roof of the tower was designed separately and all of the specifications were met.
Okay, so these are the 3 presentations that I received. I haven't received any others yet, so I guess we're done. Your job now is to evaluate these 3 presentations, including one of them. If it's your own, you evaluate it as well, and give your feedback on the forms that I emailed to you, and send those back to me, and then I will give my evaluation. Make sure also that you are checking your the grades that I sent you to make sure that you don't have any questions, and if you do have questions or concerns about your grades or any missing assignments, that you contact me immediately. This all needs to be done by Thursday so that I can get grades done. Also, you need to know that we do have another engineering class in the spring. For those of you interested in moving on in engineering, it's called Engineering 1020 or Engineering 1020, and it is a class in computer programming, a basic beginning class in computer programming. It has no prerequisites, doesn't require any special math or anything. You just get to learn how to speak to computers and to do some specific things with computers. So it's an online course. You essentially work on your own, and if you need help, you contact me, and you have videos to watch and learning tools to use, and that's all there is to it. So make sure that if you want to go on in engineering here, you sign up for that course that starts in January, and it's another 3-credit course. So it's been a pleasure teaching you. I hope that you've learned much, and have a good holiday break.